So yesterday we were talking about squares, and we broke that square into two 45, 45, 90 triangles, correct? So today I want to break it into something different. Okay, at the top of your paper, kind of off to the side a little bit, we're going to be drawing a couple of different things. Pick a dot kind of up towards the top, and I want you to go diagonally 1 unit, 2 units. And then I want you to go the other direction, 1 unit, 2 units. So then when you draw a horizontal line, you should have 1 unit, 2 units. What shape do I have? What kind? Equilateral triangle, right? Because we just went 2 units on all sides. What do you know about an equilateral triangle? Good. The angles and the sides are all the same. So all these sides right here are the same. But I also know that all these angles right here are the same, correct? How big are the angles? 60. Very good. So all of these angles right here are 60, 60, and 60. What happens if I drop this line in here and here? What is that called? What would that green line be called? It goes straight down and forms 90 degrees and it goes through the vertex. It is perpendicular to the bottom line, but we called it something specific. Huh? Starts with an A, altitude. So if I drop this altitude in, what happens to this angle right here? This angle now becomes a 30. So yesterday when I took a square, I cut it into a 45, 45, 90. Today we're taking an equilateral triangle and we're cutting it into a 30, 60, 90. So really all I want to talk about is the 30, 60, 90 triangle. So when I'm doing this, I want you just to ignore this other half. I'm not going to erase it quite yet, but I just want you to ignore half of this triangle. If this side right here is 2 units long, how big is this side right here? Well, how big is this whole side right here? 2. So how big would it be from this dot to this dot? 1, right? Everybody with me so far? How could I figure out how big this side is? Okay, so right now I feel like I can just erase this. You don't have to worry about erasing it. I just want you to think this is what we're looking at. How can I figure out how big this side is? What? How many sides do I know? 2. If I know 2 sides, how can I find the third side if I have a right triangle? Pythagorean theorem, right? So here I can do x squared plus 1 squared, because this side was 1, is equal to the hypotenuse squared. That would be 2 squared. So what's 1 squared? 1. What's 2 squared? Good. Now what? Oh, what do I do next? Subtract 1 from it. Very good. So now I have x squared is equal to 3. And then would I take the square root of both of those sides? So that means that this side right here is the square root of 3. Well, okay. Let's come over here and find another dot over here. You're going to need a little bit more room. Okay, find another dot. And now we're going to go down 4 diagonally. 1, 2, 3, 4. Go the other way. 1, 2, 3, 4. And I should be able to go across. 1, 2, 3. Okay, everybody got that on their paper? What kind of triangle do I have? Equilateral. What do we know about an equilateral triangle? All the sides are equal. How big are each of our sides? How many dots? There's 4 spaces is really what I want, right? What else do we know? Which would be 60, right? And what do I need to drop down? The altitude. Very good. I'm going to drop that altitude down and it forms 90 degrees right here. So really I'm just looking at this. Everybody with me so far? So if this side is 4, how big is this side right here? 2. Right? How can I find this side? Pythagorean theorem. I'm going to give you a second. Okay, so hopefully you set it up like this. And you got it down to the square root of 12. Just like what we've been doing right here, we just need to break it down, right? How can I break 12 down? 2 and 6. How can I break 6 down? 2 and 3. So now I have a pair. What happens to my pair? What happens to my pair? It gets to come out of the house. And what has to stay in the house? So my answer here is 2 square roots of 3. Now I want you to compare both of these triangles. Look at their numbers, look at their information. Tell me, what do you notice? They both have a what? A square root of 3. Very good. What else do you notice? How do I get from here to here? How do I get from here to here? Divide by 2, right? Let me ask another question. What would we call this side right here? What would we call that side right here? Hypotenuse, very good. What would we call this side right here? Short leg. And what would we call this one right here? Long leg, very good. There's a pattern. And I hope what you found is that my short leg is x. It's a number. And to get from my short leg to my hypotenuse, can I multiply it by 2? So my pattern for my hypotenuse is 2x. And then over here, it's whatever my short leg is with a square root of 3. So my pattern here is x square roots of 3. Again, let me tell you this again. So this is my hypotenuse. This is my short leg. This is my long leg. My pattern for my short leg is x. My hypotenuse is 2x. Well, 2 times 1 gives me 2. And then to get from my short leg to my long leg, it's x square root of 3. Well, x is 1. So 1 times the square root of 3 is just square root of 3. Everybody okay with that? Good. Now flip your paper over to the front. Okay. Here are the same problems that we just did. So what do I call this side right here? Hypotenuse. What do I call this side right here? Short leg. How do I call this side right here? Long leg. What's the pattern for my short leg? Do you remember? X. What's my hypotenuse going to be? 2x. And what's my long leg? X square roots of 3. Which number did they give me? So they're telling me that 2x is equal to 2. So how can I get what x is? When I just divide by 2? So x is 1. And if x is 1, then my long leg is 1 square root of 3. Are we okay? It's not much different than what we did yesterday, is it? Not much different? Okay, down here, what do we call this side right here? Hypotenuse. What would we call this one right here? Short leg. What do we call this one? Long leg. Let's write in our pattern. This side would be what? X. My hypotenuse would be 2x, and my long leg would be x radical 3. Here I know that my hypotenuse is 4, so that means that 2x is equal to 4. Divide by 2. So that means that x is 2. If x is 2, then my long leg would be what? 2 square roots of 3. Try the next one right there. See if you can come up with the answer. What did you label this side? 2x. What did you label this side? X. And what did you label this side? X squared to 3. So if 2x is 6, how big is 1x? 3. And how big is my long leg? Okay, now let's go to our worksheet for today. I want you to try number 1 and number 2. We're not going to do number 3 today. I want you to try number 1 and number 2. Okay, what did you name this side right here? The hypotenuse. What did you name this side? Okay, but it's a short leg, right? And what did you name this side? Long leg. So it's x radical 3, very good. And what did you put for this one on the pattern? 2x, right? I know that this is 9 squared to 3, so how big is x? X is 9, right? So how big is 2 times 9? 18. How many of you have that? Good. On number 2, what did you call this side right here? That's the which one? Hypotenuse. What was this one? And this one? What's the pattern for the short leg? X. The pattern for hypotenuse? 2x. And the long leg? Radical 3. Okay, I know that my 2x is 10. So if 2x's are 10, how much is 1x? 5. And my long leg would be what? 5 radical 3, right? Because x is 5. Are we okay? Good. Try number 4. Okay, what did you call this side? Hypotenuse. Very good. What did you call this side here? Short leg. Very good. What did you call this side here? Long leg. Now tell me the pattern. My short leg is always x. My hypotenuse is 2x. Okay, your hypotenuse is always your 2x. And your long leg is x radical 3. Wait a minute, Mr. NZ, that doesn't have a radical 3. Remember, just like on the 45, 45, 90, sometimes it hides inside. Right? So this is where we're going to have to work them, just like what we did before. So I know that the pattern is x squared to 3, and the answer is 12. So x squared to 3 is equal to 12. What would I do first? Good, we're going to divide by radical 3. Can I leave a radical on the bottom? No, so I need to multiply the top and the bottom by radical 3. So on the top I have 12 radical 3. And on the bottom I have a pair. What happens to the pair? It gets to come outside and play. So 3 and 12 are both outside. How many times does 3 go into 12? 4. So that means that x is 4 radical 3. Well, what do I have to do to get to the hypotenuse? What do I have to do to the x? Multiply it by 2, right? So what is 2 times 4 square root of 3?
8 radical 3.
8 radical 3, very good. So 8 radical 3 is what my hypotenuse would be. Okay, you had the bottom 5, 5, 6, 7, 8. Okay, that's your homework. But you have time.